Here we have a linked list example here. And one of the nice things about a linked list is that it has some really key elements of efficiency with things like insertion or deletion from a list if you don't care about accessing the elements, or in this particular example here, if you want to insert or remove elements from the middle of the list. But it's actually a much more rare data structure to use, and it has a higher memory overhead and worse cache locality than either VEC or VecDec. Let's go ahead and take a look at how we would use it, though. So again, I make this very similar to a previous VecDec example here, except for I use linked list. At the very beginning here, I go ahead and I push these elements into the back of a linked list. Now, here I do something a little bit unusual is that I convert it back to a vec here just to keep it similar to the previous vecdec example here. Probably wouldn't do this in the real world. And then after I shuffle it, I move it back into the linked list, and then I push the fruits to both the end of the list after shuffling, and then I go through and I print it out. So really the idea here is that it's a specialized data structure that has a few unique properties, but most of the time you're better off using either vec or vecdec. Let's go ahead and do cargo run. There we go. We see that we're able to actually do a very similar operation to vecdec. All right, here we have a Rust command line interface. It's very similar to, let's say, Python's argparse module. The idea here is to use a command line interface to give us a little bit more flexibility when we're building things. Now, let's go ahead and take a look first at the structure. So here you see that there's a source and a lib and a main. So by default, in Rust, if you wanted to put some library code together, you don't need to do anything other than inside of source, create a lib.rs file. In this case, this is the lib.rs, and I would go through and I would put in my logic. So in this case, I expose the function. So I type in pub, and this makes an item visible to others. And then I create a vec here. So this is pretty simple. I create a vector that includes strings inside. So I say vec string. And now you just go through here and you say to string, to string, to string, right, to all of the fruits that I add inside. Then what I do is I do a shuffle right here. So I kind of move them around to make them unique on each iteration. And then I put them back inside of here. So once I've got this ready to go, then I can go to the main. And in the main here, at the very beginning, we have the clap parser here. This is, again, similar to Python's argparse. And then all I need to do is say use CLI salad, create fruit salad. Now, where did this create fruit salad come from? Well, it's right here. I publicly exposed this function. And now how do I know about the namespace though? Well, all we have to do is go over to cargo 2ml and notice here, the name of this package is called CLI salad. It's going to put the hyphen here and make it into an underscore. So if I go back here, so here what we can do is we can see that in fact, you do have this ability right here to use the first namespace, which is the name of the project, and then that publicly exposed function, which is implicitly inside of lib.rs. So this is a nice pattern that saves you a lot of time. I go ahead and I put some default things in here like version, author, etc. I use the options to give me something that I can pass in. And then from here, I can get the number of fruits that a user requested. And then I go through here and I basically tie it all together. So pretty easy to use. So let's go ahead and cd up a directory here, go into CLI salad. And now if I type in cargo dash dash, that will actually pass what I'm going to do into the command line framework. So this is really important. This can be very confusing is when you're using a command line tool library is to use this double hyphen here, then pass in the argument. So there we go. We can see that it gives me back the help message, which then lets me do other things like use the number option here. So let's go ahead and do that. Let's type in cargo run, and then I'll type in number, and we'll say 5. Here we go. Created a fruit salad with 5 fruits. If I want to go ahead and I want to add 10 fruits, there we go. it's going to go ahead and add 10 fruits inside of there. So this is a great way to really extend what you're doing once you get used to writing scripts inside of Rust. Use clap here to extend it. It's pretty straightforward to do. And then also, one of the great advantages is you now can do binary based deploys and give someone your command line tool. All right, in this demo, I'm going to show a HashMap frequency counter demo. One thing to consider about HashMap is it's very similar to a Python dictionary, and a good use case for it is to have a frequency counter or to count things in general. And it has O to the one time complexity for insertion, deletion, and access. So it's a great really multi-purpose data structure in Rust that you'll use quite frequently. And they're great for tasks that require a quick lookup, like counting occurrences of items. So let's go ahead and walk through this code here. Inside of the main, we've got a hash map inside. And then I have a function here called logic. And inside it takes numbers, which is a vector, and I say let mute frequencies, and then I go ahead and create a new hash map. Now, inside of here, what I do is I count the frequencies here by doing an incrementer. And then when I go ahead and I look at the result, I return back a vector to make it a little bit easier to push out the results. And then finally, here is the main invocation here in the main function. I say let numbers, and I create a list of numbers. So notice here I say 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I include a couple of duplicates so that I'm able to verify that is going to count the frequency correctly. Now, this could obviously be a huge string of numbers, but just for a demo, I'm going to make it pretty simple. And then I go ahead and I call that other function above. So this is a great way to organize your code in Rust, is to have a little bit of logic somewhere if it's a simple script, if you're not going to make a lib.rs, and then call it from the main function. That way the main function isn't, this huge mess and it's hard to read. And then I go through here and I print out the frequency of each number so that I can explain what it is I'm doing. Because if you just print out, a vector, for example, it would be a little bit difficult to understand what does it do. So it's great to put a message here that says exactly what I'm doing. So I'm going to go ahead and type in cargo run. And you can see here it says the frequency of each number in the vector is, and then we can see 1 occurs 2 times right here, right? Because we know 1 is here, 1 is here. And we can say 5 occurs once, 7. So everything occurs once except for 1 and 3, which should have 2. And of course, that's exactly what happens. So a very useful general purpose data structure, pretty simple to use as well, is a hash map. It has great performance. So between a hash map and a vector, you can really do, a wide variety of things in Rust. And these are probably the 2 data structures to focus on the most. And they have a lot of similarity to how you would do things in Python. All right, so here we have a hash map example that is really fitting for, let's say, a data scientist or a data engineer, where a lot of times you'll need to create your own custom metrics. Maybe those metrics will be fed into a dashboard or, a database or something like that. In this case, I've gone through and used HashMap up here and created an init languages function. Inside of here, we see that I've created a mutable hash map. Inside this hash map, it's going to contain strings that are I32. We have JavaScript, HTML, Python, SQL, TypeScript, Bash Shell, Java, C Sharp, C++, C, etc. And what's really interesting is once you start diving into the age of the languages here, it's a good thing to mix in with the popularity. So what I'm going to do is I'm going to make another function here called calculate weights. And what this calculate weights accepts is the years active. And what it's going to do here, it's going to calculate how long a language has been active. Then what I'm going to do is I'm going to take the languages here and knit it, calculate the weights here. And I'm going to say the language weighing from 1 to 100 by age 1 is the newest, and 100 is the oldest. So let's go ahead and do that. And what's nice about this, again, is this would be a similar type of operation that you would do as a data engineer or data scientist to create your own custom metrics that feed into a dashboard. If we go ahead and we type in cargo run, look at this. I could actually rank a language in a very different way in the fact that in this particular weighing here, I'm going to say language weighing from 1 to 100 by age. 1 is the newest and 100 is the oldest. So if we look at this, we can see here that TypeScript is the newest. Rust is also pretty new. C is actually the oldest one. And so, really depends on what kind of thing you're thinking about. But should you be using Python, maybe for very stable projects? If you want to do something more cutting edge, maybe you should start to look at things like Rust or TypeScript. If you want something that's a little bit in the middle, C Sharp, for example, is ranked 30. So this, again, is something very similar, and it's that you would do as a data engineer, and it's quite trivial to do in Rust, and the performance is going to be incredible because it's a compiled language that's modern, and it uses a very efficient hash map to do the calculation.